So this is the something which we have to do that. So are you able to see my screen, right?
Yeah.
Okay. So yeah, remember that these the locations which if you any modifications you do, my request is like don't change the path, but change the file. That will be easier for you. Okay.
Of course.
So now you know the locations and everything. So it has to be rotated way. So this is the API server manifest. This is the etcd manifest. If you want to change it, this is the config file for the kubelet. This is a kubelet config file and stuff like that. Now, using the certificate API, this I have done just now. Okay, just be aware of it. This we did it just now. User names and
Correct.
user. And CSR we created, and then manually I created a CRT. Now the question is manually I did this manually. So the question is how do we do that automated way? So during the sessions you have to practice through the automated way. So what automation? So here approving the CSR and converting to the CRT, there is one API. Now what is API? And do you know
Yeah. I know.
that API? What is the API resources? Understood? This is the API. Let me show you here. So this you have to practice it. This is important. So QCTL API resources. Okay, here too many 57 resources right now, and I am just grabbing -I signed, and I'm talking about this one. So you have to use this one CSR command line. I showed you manually just to build understanding, but
Yeah.
you have to practice this one through this API resources. My questions to you: do you know this, or you want me to show you the demo for this?
No, I'm familiar with this. Yeah.
Okay, so yes, you have to use that CSR for getting done, and that is important part of your flow. So
Sure.
I think demo I have shown you already. If you want the CSR demo, I can show you one more time, but that is done. Now these are the controller manager YAML. Again, you have to get comfortable and get good. So now the topic which is very important for us is like understanding the Kubernetes, how this Kubernetes use the TLS certificate all over the components of the Kubernetes to encrypt all the communications. Are you comfortable with that?
So could you repeat that?
So how this Kubernetes is encrypting all the components internal of communications, securing the internal communication.
Yeah. So I mean, I understand because we went through the configuration and all. So I have understanding of that. Yeah.
Yeah. So now next topic what we have is network policies. Okay. So do you have idea about the network policy?
Yeah, a little bit. It's like you also mentioned about the firewall, right? So
Yeah,
to control the traffic between because by default all the namespaces can talk to all the namespaces in a default installation, right? So you have to restrict the traffic between them.
Yes. So now that we are going to discuss about it. So let's get started. So network traffic, how do we restrict? Now this traffic, I'm not talking about outside of the cluster. Remember that we are learning only the Kubernetes. So only inside the cluster, how can we restrict that? So here, if you look at this, I have already said, so you are comfortable with it. There are different level of firewall is there. One is network level of firewall you have, OS level of firewall you have. Right now, I'm talking about the Kubernetes firewall. I mean Kubernetes cluster related firewall right now, network policy. But if you're using this this one, what is it? This console and all or Invo and all, then you can have a service-based firewall also is there. So multiple level of firewall are there, but right now I'm talking the network policy which is inside the cluster. So now if you see that the regular flow, it should be like user is hitting to the website. It's a very simple flow, not microservices. It's a, you can say, SOA. So service oriented architecture. So here web is hitting to the API and API is hitting to the database. So in any case, web should not hit the database, correct? No?
Correct.
And here API should be only accessible. Here, if you look at the security check, few check, though it can, the situations will be complicated when you get into the microservices. So here, API should not be accessible by user. Okay, user should only access web. Web should allow the access only from the user. API should be only connected from the web, but not from the database. And database should be only connected from the API, not from the web. Correct now?
Yeah, yeah.
So this is a very small setup. So how can we restrict this process? So here you see that here ingress is 80. That means allow traffic at 80. And egress means outgoing traffic.
Outgoing traffic.
Yeah, outgoing traffic is 50-50. So how do you set this at the web level? Same thing you can set ingress and egress at the API level also. Same thing you have some egress and ingress for the DB level also. So the question is, yes, you understand more or less what should be allowed, what should not be allowed, but how do we set in Kubernetes? So that is where we are going to use network policies. Network policy is one of the API resources of Kubernetes. Let me show you. Now, if you're not comfortable, spend time like me only. So here I do network. Okay. And here, this is the one I'm talking about. Okay, network policy. Now, how I learn, I'll tell you my tricks. So kubelet, there is one command which is called explain.
Explain.
I think you know that, right? Yeah. So that's a
Yeah,
good
yeah.
thing. So here, this one I do and I enter. I read this, then I do dot spec. Then again I read this, and then here I set ingress and egress. So let me show you the ingress and egress dot. And this is
Dot
how
ingress.
that's how I learn. You can do that during the session. I think you know that all this stuff. Now let's say you want that quick command to be setting up for the ingress and egress. So what to do? Kubectl this command -h and oh sorry. So kubectl create.
Create.
Yeah. So here this is not supported. Network. No problem. So just a second. Hold on. I'll have some alternative also.
Sure.
Network policies not there. So
I think some we can create only by the YAML files.
yeah, YAML, but yeah, there's a way to do that. Just let me try.
Okay.
Just a second.
Sure.
Run -h. Run can be used for
And is to run a pod.
deployment. Yeah. Okay. So I'll just tell you the tricks. I'm not. I'll just open up my notes a little bit later and tell you. So now
Sure,
this is
sure.
the application diagram. So now all Kubernetes pods are in the same. Just all Kubernetes pods are in the same virtual private network. Remember that. So
Yeah.
that is the one thing. So you can use network policies like Flannel, Calico, and Selenium and VBNet. Right now in this session, I'm using Calico. Flannel and VBNet tutorials, I showed you how to get it on my blog. You can get the blog's URL. Search for that VBNet, you'll get it that with the Kubernetes.
Okay.
So now network policy. So Kubernetes resources that control the traffic between the pod. Remember that between the pods and or network endpoints. What is the network endpoint in Kubernetes? Network endpoint.
Service.
Services, yes. Endpoint is always services and pod and services deployed at the namespace level. Okay. So this is one. So I want to show you one thing. see here network policy, and here true. True means what? True
Enabled.
means enabled means.
Not sure what is that true.
So true means, see here. Get comfortable with this one. This column. Namespace true and false means what?
Is
Namespace.
scoped at the namespace.
No. See, I'll put it in a very simple way. Any resources where you see the true, that means that resources can be created only inside a namespace. Okay. Then you will say, what about after the namespace? Means out of the namespace is the cluster, right? Cluster
Correct.
have a multiple namespace. So any resources which we say false, like namespace, is at the cluster level. Remember, but pod is at the namespace level. Node is at the cluster level. Somewhere node you'll have. Where's a node? It should be here only. It's here. So here false. Why? Because node is at the cluster level.
Cluster level.
Yeah.
Okay.
So so what I was trying to tell you here, my network policies you can create at namespace level.
Namespace level. Okay.
Got it? So remember that you can create a namespace level. So that means using the network policy, you can control the pod networks which is in the same namespace. Make sense? So if you want to control the pods which is in the other namespace, you have to create a network. You have to create a network policy in that namespace. Okay. Let me tell you, the network policy is a very important topic for your exam, for your learnings. Okay. So
just a question. Sorry, just a question, Rajesh. So can I go ahead?
Yeah, please.
Yeah. So you said if I want to control the network policy for a pod in a namespace, I have to create the network policy there, right?
Right.
But suppose between two namespaces, if I want to allow or restrict the traffic, so I will create in the source namespace or
No,
the target
typically
namespace?
we don't do that. We work with the services. So every services has a DNS entry. Remember that in the cluster level.
Correct.
So you can use the service level DNS entry for that.
No, but in which namespace will that network
Okay,
policy be
I'll put it in a simple way. You know AWS, correct now?
I mean, at a high level, yeah.
Yeah. You know VPC?
Yeah.
So when we set a security group, security group in AWS, we set it at the VPC level, right? And
correct.
And we apply to the some of the EC2 instance. You may not apply to all the instance, but some of this. So network policy you create at the namespace level. Apply to the pod whichever you want it. That means anyone who's trying to access that pod or services, service is also namespace level. Remember, pod is also namespace level. So anyone who's trying to access that pod or service will be having applied that network policy. That means if it's not fulfilled, that connections will not make it. Simple.
Okay.
Yeah. So this is the. So how do we restrict the communication between the pods? Okay. So this can be a service or this can be pod also, anything. So for that, I need little help from my tutorial. Network policy Kubernetes DevOps. Okay. So this is the tutorial. Now I'll share with you. Don't worry about that. So I'll just run through that. So are you able to see my screen, right? Yeah. So here, understand that if you want to control traffic flow at IP address or port level, that is a part of the OSI layer 3 and 4. What is the OSI layer 3 and 4?
Yeah, the networking.
This is
We
a
have the
network
7
layer.
layers.
So this is a L3 is the network layer. Okay. Abstract net DP. DP. This is a 4 data length. Okay. Yes, I was forgetting. So this is the just for the cheating purpose. I remember the OSI layer. Abstract DP we call it. I call it. Abstract
Sorry,
DP means
what do you call it?
Abstranet DP. Let me put it up. Probably you will also use this. It's work for
Oh,
me.
it's some like we did WebGear kind of thing. So to
This is
understand
a shortcut. Abstranet
apps
DP. A
transport,
for application,
transport,
P for presentation, S for session, TRA for
trans.
transport, network, data link, and physical. So this is the L3, and this is the L4, L5, L6, L7. So L4 is transport. So I think this is the L4. Correct?
Mm-hmm.
Yeah. So if you want to control a traffic at IP address or port level, L3 and L4, then you might consider using Kubernetes network policy for particular application in your cluster. Network
Okay.
policies are an application-centric construct which allow to specify how pod is allowed to communicate with the various network entities. We use word called entities here to avoid overloading the more common terms such as endpoint and services. Okay, that means
Got
this entities means endpoint and services. So if you get endpoints, get services, you'll get to know all this stuff like. Network
it.
policies apply to a connection with a pod on one or both ends. Both ends you can apply and are not relevant to other connections. The entities that the pod can communicate with are identified through a combination of following three. So other pods that are allowed, sorry, exception a pod cannot block access to itself. Okay, namespace that are allowed. Okay, and
Mhm.
IP blocks. Okay, that are allowed. That means here exception traffic to and from the node where the pod is running is allowed, always allowed. Okay, regardless of IP address of the pod or node. So now the question is, how can we define? So this is the one image. You can see that you can. Let me show you that directly the code. Okay, see here.
Mhm.
This is the what you want. Kind is equal to network policy. Okay,
Yeah.
and in the spec, which port it should be allowed. So here you have used the port selector. That means any pod in that particular namespace, which is sync-ns, any pod in that namespace where the label of the pod is done with a 2 : and sync, that will have a this network policy. Are you understanding?
Yeah. Yeah.
And here, what you are doing, the policy type, it can be two policy type, ingress and egress. So here,
Egress.
so here you will have an example of ingress. So now what you are saying, hey, from namespace selector match label network namespace source ns. That means ingress you are allowing from the all the network. Okay, all the call which is a part of this source ns. This means network namespace source ns. Source ns is here. This is the network
Got it.
namespace. Yeah, and here
Mhm.
which are the pod from which are the pod. So the in the source ns, the pod which is having the label with from a source. Are you understanding?
Yeah. So not all the pods from that namespace, but only the pods which match this label.
Label, yeah. So from the namespace, that pod will be having from and source. In this source namespace, that will be allowed. So here you said ingress allowed. Okay, so it's here you are not spelling the port specification. I'll show you the multiple code. Just give me some time. And here, what you are saying, here you are saying ingress, egress. Okay, so egress here you setting the opposite way, and then so this way between the two namespace and certain pod of this particular namespace, you are allowing ingress and egress, and this is how you can write a network policies. So you can make a mapping of here, so which is allowed ingress, denied ingress, network policy, and most of like that. Are
So
you able to
these
understand?
two policies are, yeah, yeah, these two policies are mutually exclusive because, I
Yeah,
mean,
mutually exclusive. Yeah,
and they both are ensuring that no other traffic is there.
allowed actually. Yeah.
I mean, yeah, okay, okay. Mhm.
Yeah. So now I'll go one by one, and you look at this here. This is a simple stuff. Deny all traffic to an applications. So we have to deploy one applications, and deny all the traffic. So there's one namespace default, and there's a namespace prod. We'll create this scenario, and here we will deploy one particular app. Okay,
Mm-hmm.
and
Okay.
there from there we'll try to connect from the other container and see that if it's accessible or not. Okay, so any other container, if you want to see that the pod app is equal to web, so all the traffic, that means other any container or pod should not access this pod, but this pod should access any other pod. So deny all traffic to an application. So how you do that? So let's look at the code here. This is the code we can use it for network policy. Okay, how to apply and all, yes, you understand this. So
Yeah,
here
yeah.
we are working, so network policy, and name of this network policy, and here spec ingress. You are not setting egress because you are allowing, right? Egress is allowing. Ingress means who should talk to me.
Mm-hmm.
So here, who should talk to me? So ingress, you are blocking. You are not allowing ingress for anything. So just make it empty. Make it.
Uh, so yeah, just a question. So the network policy by default it is only deny, and if we
Yeah,
have
by
to
default
allow,
deny.
we have to do a exception.
The moment you create a network policy, by default, it's a deny. That's a
It's a deny.
that's a major security practices which we have. Default deny. That's a rule of the security. Practices, best
Mhm.
practices. Default deny.
Yeah, yeah. Okay.
So if you want to allow, then you'll have to do that. So now we can do this here. We'll have to deploy some pod. So let me deploy some pod using this one. So here, this command, I don't think so I have to explain it to you. So
Yeah, it's clear.
copy. So here, this is the one service, one pod, kubectl, get svc, and get pods. Here you have. Now it's creating this wait for it. It's a lightweight only. Now after that, run a temporary pod to make a request to the web services. So this will make a request to the web services. This is a temporary pod, and it will make a request to the web services. So here, random, we need to set this. This command will make a temporary request to this. You can also do this SSH call and stuff like that. After that, create a network policy. So let's make a manually connection. So before running this, vi network policy dot one dot YAML. This is the default namespace. Sorry.
Mhm.
Now I just apply this. So here, remember match labels of the web. Here, if you look at this, while creating, we
Yeah.
are doing app is equal to web. So do this. Okay. Wait a second.
The
My
network
name
policy.
is network.
Mhm.
Done. So now kubectl get pods right now running. Get
Network policy.
net all. That's a shortcut.
Mhm.
and here you have a network policy. So now what I'll do, I will create one more pod just for the sake of my demo. So this is, I'm creating one pod, and okay, this is my pod, name is equal to Raj. So run web. Okay, web.
Web is the name already.
Yeah.
Yeah.
So web image nginx. Done. Okay, I knew that. Hyphen name Raj. Name. Wait a second. Mm,
Why is it saying web is already running?
I have already run last command. Okay, let's change the name and Raj. Okay, so this is the one pod I created. kubectl get pods -o wide. So now, guys, I have this is my one where I'm applying the network policy, and you can do show labels to match the expectations also. So now what I will do, I'll go inside this particular uh, uh, web, pod. So kubectl exec -it, and what is this, web, right? So web and bin bash.
Bash.
Now ping this IP address, which is self I'm pinging. Okay, first ping is not there, I know that. So if this I'm doing manually, okay, you can use this image also, Alpine image, but right now I'm just showing you manually so you understand this stuff. Later on, you can do all these automations.
Sorry.
Net tools actually. Install. Ping is there now? No. Ping in Ubuntu. Install. Utility is what?
Net utilities.
Oh, I okay. Done. Yes. So I lost this, all the output. Is there. So I'm pinging myself, okay? So ping self. And it's accessible, no problem. And I'm pinging now the pod. Wait a second, what I ping? I'm inside the web, right? Okay. So I can ping myself, right? That's not a problem. Now I'll go to exit. Now I'll do this Raj. That was where I applied it, right? Raj. Now, just a second. And done. Yes. And the IP address is. So here I'm inside the Raj. Can I ping the to web?
Web.
Yeah. So
So
ping.
this should not be allowed, no?
No. And you see that it's not allowed. Got it?
Yeah, got it. Yeah.
Okay, so I'll show you that tens of different scenarios also. Just many scenarios are there. We'll discuss this one. This is a very important topic for your perspective. You have to get into that. Okay, so before that, let's have a lunch break and let's meet up at 2 p.m. IST, and then we'll continue the session. Okay.
Sure. Yeah. Okay. Thank you.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to hundreds of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.